Right guys, here we go. So we're going to look at limiting reactants or limiting reagents. So this is a relatively difficult GCSE question, calculation question using moles and masses. So here, as you can see, we've been given the mass of aluminium, 108 grams, and the mass of copper chloride, which is 1.2 kilograms. You have to work out how many moles of each of these two reactants you have. And the easiest way to format this is mass, MR, and moles. 108 grams of aluminium. We know we've got 1.21 kilograms of copper chloride. So we know there's 1,000 grams in a kilogram, so we need to convert that into grams so the number of moles is correct. So we literally times that by 1,000 and you get 1,210. The MR of aluminium is 27 and the MR of copper chloride 134.5. You do not use the big 2 and the big 3 when you're working out MRs ever. You only use a 2 and a 3 when you're comparing the mole ratios, which we'll look at later. If you format it in this way, the number of moles is dead easy. That's a fraction, 108 over 27. 4 moles, 1,210 divided by 134.5 gives us the best part of 9 moles, but 8.99 if we want to be accurate. So now we know the moles, now we can compare them, now we can find out which one is the limiting reagent. And the best way to do that is this. Initially, what I want you to do is to forget that we've worked out our 8.99. And we're going to calculate how many moles this 4 wanted to react with. So if there's 4 moles of aluminium, because this is a 2 to 3 ratio, and we know it's a 2 to 3 ratio because we've got a 2 and a 3 in front of the aluminium and the copper chloride. If we've got 4 moles of aluminium, that would want to react with 6 moles of copper chloride. Okay, because the same 4 to 6 is the same as 2 to 3. So we had 8.99. 8.99 is larger than 6, which means this is the excess reagent. You can check that in the opposite direction. So what I'm going to do this time is I'm going to rub out the 4. In the exam, you just cover this with a pen or something. And okay, here we've got the best part of 9 moles of copper chloride. So working backwards, if it's a 3 to 2 ratio, and we've got 9 moles of copper chloride, how many moles of aluminium would it want to react with? Well, 3 to 2 is the same as 9 to 6. Okay, so it would want to react with 6. But how many have we got? We can remember that we had 4, which is less than 6. So this is your limiting reagent. So the trick is to cover one of the number of moles up, and using the mole ratio in the equation, work out how many moles the other one would have wanted to react with. And then you can find out whether it's limiting or excess. You don't care about the excess one. That's not important. The limiting one limits how much copper you're going to make. So we care about this column here and this column here. We don't care about anything else in the equation. We know, as we've just worked out, there are 4 moles of aluminium that we've got. So again, using the big number 2 from the mole ratio in the question, and the big number 3 because that's the number of moles of copper that it will produce. 2 to 3 is the same as 4 to 6. So we know 4 moles of aluminium, the limiting reagent, will make 6 moles of copper. We know from our periodic table that the MR of copper, again, remember, we don't use the 3 unless we're doing the comparison. Working out the M, you don't care about the big numbers. So from your periodic table, or they might have given you in the question, sometimes depending on what level, the MR of copper is 63.5. And to work out mass equals MR times moles. 6 times 63.5 equals 381 grams. That will be lots of marks. Follow for more.